In this video, we will be learning about acid and base neutralization reactions. This is to work on our learning objective for describing acid and base reactions. So acid and base neutralization reactions are going to follow our double displacement reaction pattern. When you mix an acid and a base together, they will form a salt and water. This is a good pattern to remember. Acid plus base equals salt and water. This can help you remember what you're trying to make. And so you do need to swap your cation and anion pairs. So if we look at this example here, we have nitric acid and sodium hydroxide. Sodium hydroxide is formed out of my sodium cations and my hydroxide anions. And so my sodium cation will bond to the nitric anion from the acid. And that's going to make my salt. And so I'm going to have my sodium and my nitrate. By salt, we just mean an ionic compound. So any ionic compound can be classified as a salt according to chemistry. So on my solubility rules, sodium nitrate is going to be aqueous. So I can give it state of matter. Now water. Let's look at our other pair. We have the hydrogen here, which is my H plus cation, and that's going to bond with the HOH from the base. And so that will be HOH, which is 2 hydrogens and 1 oxygen. And so that is H2O, which is water. So we have an acid plus a base equals salt and water. We call this an acid-base neutralization reaction regarding its pH. If we remember, a neutral pH is pH 7. So if I have just the right amount of acid and base and I mix them together, I will end up with a neutral pH because I will be making pure water out of this. Salt water should be neutral. If I have a little bit extra acid, my pH will still be acidic. If I have a little bit extra base, my pH will still be basic. But if I have just the right amount of each, then I should end up with a perfectly neutral solution. So here's a practice problem. Go ahead and try to write out the balanced molecular equation, complete ionic equation, and net ionic equations for the reaction that occurs between nitric acid and barium hydroxide. Pause the video to work this out on your own in your notebook, and then unpause the video when you're ready to continue. All right, let's go over this. So the first thing we need to do is decipher our chemical formulas from these names. So nitric acid, it doesn't start with a hydro, so I know this has to be an oxy acid. It ends with ic, and so eights get changed to ic, because if I ate too much, I'd feel icky. And so that's going to come from nitrate. And so I need an acid between nitrate and hydrogen. So that's HNO3. So HNO3. And acids are going to be aqueous in solution. For barium hydroxide, hydroxide, according to my polyatomic ions, is OH minus, and barium is in group 2. And so that's going to be barium 2+. So my neutral ionic compound formed between these two is going to be barium hydroxide. And barium hydroxide is going to be soluble. It's an exception to being insoluble. So I'll do my molecular equation first. Then I will have my double displacement reaction pattern where I will bond my nitrate with my barium to form my salt. I can see that that's a -1 ion, and that's a 2+, and so I'm going to need 2 nitrates. Barium nitrate is soluble like all other nitrates. And then I'm going to form water with my remaining ions. Remember, acid plus base equals salt and water. The state of matter for water should be liquid, not aqueous. Now I have to write my complete ionic equation. And so here I'm going to have my aqueous strong electrolytes written as ions. And so I look at my states of matter: aqueous, 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 not aqueous, don't ionize the water. Now I look for strong electrolytes. This one is a strong acid, so it will be ionized. Barium hydroxide is a strong base, and it's ionic, and so it will be ionized. And that's ionic, and so it will be ionized. So in my complete ionic equation, I will have H+, aqueous, and NO3- aqueous, and barium 2+, aqueous, and 2 hydroxides, aqueous. Did I balance that? I didn't balance it, did I? Hold on. Sidetrack. Let's look at this. 2 hydroxides, 2 nitrates. I'm going to need 2 acids for that. And so that's going to give me 2 H's for 2. Okay. So I need a 2 there and a 2 there. I think we're good now. All right. Always remember to balance. And as you can see, sometimes I get carried away and I forget such details. But I catch myself, and that's what's important. So that's going to give me 1 barium and 2 nitrates, and then I do not ionize my water. Now I can look to see if I have any spectator ions, and I can see that my nitrates are going to cancel out, and my barium is going to cancel out. And so my equation, 2 waters. Catching myself all the time. Okay. So 2H plus 2OH minus forms 2 waters. But we got to simplify this because we want the lowest whole number. And all of these are even. So we got to cancel this out to simplify it to just H plus OH minus, both of which are aqueous. And that will form 1 H2O, liquid. And so underneath all this, there's the writing. Here's another practice problem for you. It says, again, to write the balanced molecular equation, the complete ionic equation, and net ionic equations for the reactions that occur between acetic acid and sodium hydroxide. Go ahead and pause the video and try to work this out on your own. Unpause the video when you're ready to continue. All right, let's go over this. All right, so we have acetic acid here. Acetic acid, it doesn't start with hydro, and so I'm looking for a polyatomic ion that's acetate. Acetate is down at the bottom of your green sheet, which is C2H3O2 with a 1- charge. And so acetic acid would have the chemical formula HC2H3O2. Now we have sodium hydroxide. Sodium hydroxide is going to be made out of my sodium cations, which are in group 1, and my hydroxide anions, which have a 1- charge. So sodium hydroxide is NaOH. So if I write this out, I have my acid, H2, HC2, H3O2, aqueous, plus my base, NaOH, aqueous, and then that's going to become a salt of sodium and acetate, and so that's sodium acetate, and that's going to be aqueous according to my solubility rules. And then my other product will be water, because an acid plus base always equals salt and water. So that's my molecular equation. Next, I'll do the complete ionic equation. So now I have to go through and I have to identify which are strong electrolytes that are aqueous. This one is aqueous, but it's not a strong electrolyte. That is a weak acid. And so weak acids are not strong electrolytes. They are weak electrolytes. Then I have sodium hydroxide. That's ionic and a strong base. And so that one is a strong electrolyte. And so that one will be ionized. This is also ionic. It's an ionic strong base. This one's ionic, but not a strong base. But it is ionic, so that one will be a strong electrolyte. And it is aqueous. So it meets our 2 requirements for ionizing. So when I write my complete ionic equation, I do not ionize my acetic acid because it is a weak acid. And then I will ionize my sodium hydroxide. And I will ionize my sodium acetate. And remember, we wrote up the ions up here so that you could refer to them quickly. And then water will not be ionized either. So now when I simplify, I don't actually have that many spectator ions. Everything is a 1-to-1 ratio here, so I am balanced. But my sodiums will cancel out, and then I'll be left with my net ionic equation, which will include my acetic acid and my hydroxide anion, forming acetate anions and water. That's a 2 down here. If you have any questions about that, please let me know in our class forum.